Good evening, everyone, guys. Welcome to CS Saturdays. This is Prashanith from coding.Studio. This week, we're going to cover quick sort. So, what is sorting actually? Sorting is a way of arranging elements in a certain order. The order may be ascending, descending, or if the elements are strings, it might be in alphabetical order, etc. So, we're going to cover quick sort technique this weekend. So, without any delay, let's get to it. So this is going to be the agenda in today's session. Firstly, we'll talk about quicksort. Then we'll go with the example. Example. After the example, we'll go with applications. Applications followed by time complexity. In time complexity, we'll also compare the compare the quicksort with other sorting algorithms. So what is quicksort? Quicksort is an algorithm developed by Tony Hoare. It is the most widely used algorithm, and basically it's faster than merge sort and heap sort. So basically it falls under the category of divide and conquer approach. And the process behind this is it works based on the pivot. So firstly, in quicksort, we select a pivot from an array or a list. So the pivot partitions the elements into two subarrays, and the elements to the left of the pivot are always less than the pivot, and elements to the right of the pivot are always greater than the pivot. So after selecting the pivot and dividing it to two subarrays, this process continues recursively until all the elements are sorted. After the first pass, uh, one element gets into its correct position. So divide and conquer approach. So what is divide and conquer approach? Quicksort follows divide and conquer approach. So divide and conquer approach means that basically if you have a big problem, that problem is continuously divided into several subproblems until the smallest unit is easily solved. If the smallest unit of the problem is easily solved, then that result, smallest unit is result, uh, uh, is return smallest subunit answer is returned, which which is used by the bigger problem to solve the bigger problem. So quicksort uses divide and conquer approach. So with divide and conquer approach, the bigger problems like sorting and there are several other major problems, uh, we cannot work completely on the superset of data. This would increase the complexities, and this would also require a lot of resources. Hence in divide and conquer approach, we divide the problem into subparts, thus reducing the amount of usage of memory as well as time, etc. Uh, so without any delay, let's get to the next section. So before explaining the quicksort concept, let me explain you let me go through this example. So consider a class containing around 20 students. Uh, uh, Consider they are standing in an assembly, and they have some random heights. So if they are told by his teacher to stand uh, in an in the order of their increasing heights, so obviously the shortest and longest persons would obviously know themselves easily, and the longest person would go and stand behind all of this. Shortest person would definitely go in front of everyone. So what happens, the problem is, uh, how do we sort the remaining members other than the shortest and longest ones? So what happens is someone takes initiative, and he's a pivot, and he comes up and says, hey, you are shorter than me, just go in front of me. And he observes another person, hey, you are taller than me, just move behind me. And in that way, using that pivot, he sets every other person's ahead of him and behind him. So this is the exact way how quicksort works. uh, if the pivot says, if you are, you're smaller than me, just move ahead of me, just be in front of the array. And if the pivot is, if the element is greater than pivot, yeah, you're greater than me, just move behind me. So in this way, it follows. This approach is followed in quicksort. So quicksort basically contains three steps. So first, quicksort. You choose a pivot element. So there are several ways to choose a pivot element. In the following example, we have chosen the first element as pivot. We'll discuss the few more things later. So we choose a pivot element, and we arrange the numbers in such a way that uh, left of the pivot are always less than the pivot, and right of the pivot are always more than the pivot. So what we do is we select we so for example, so if you look at the picture here, uh, we selected 5 as the pivot, and after the first pass, the 5 gets into optimal position, and the numbers to the left of the pivot are always less, and the numbers to the right of the pivot are always more. So uh, we arrange in such a way. So what happens here, so once if you check the subarray of the subarrays to the left of pivot, you see that they are not in order. So what we do is we just sort the what we just quick sort the left subarray, and then right subarray. So until we get the sorted array, we just keep doing it recursively. So those are the second and third steps: quick sort left subarray and quick sort right subarray. So uh, for the for the for sorting problem, if we solve in quicksort using quicksort, we need to first select pivot. So a pivot can be selected in several ways. So we can pick the first element as pivot, we can pick the last element as pivot, we can pick the random element as pivot, and we can pick the median element as pivot. Although any approach leads to the same result, that is we're gonna get the same sorted array, and if we do it perfectly, we'll just get this correct answer every time we select, even if we select the different pivot. So in this video, we're gonna follow selecting the first element as a pivot. uh, so uh, so basically the slide shows the steps to follow to quicksort an array. So first thing is, we are going to get an array, and we gonna choose the pivot, and as we follow choosing the first element as pivot, follow the method of choosing the first element as pivot, we'll select the first element as pivot. So then next is, we need to choose 2 points. So those 2 points are p and q. So pivot is different from p and q. So p, we select p is a immediate is immediate right to the immediate next element to the pivot, and q is the last element of the array. So, and one more thing is, we need to add the infinite to the last element. Yeah. uh, After selecting q, we need to add the infinite to the last element. Then, so we have assigned the variables. Now the method is, we need to move the pointers. So let's see how we move. So we need to move the pointer p ahead until value of p is less than pivot. So if you observe that, if the pivot value if the value of p is less than the pivot, we need to move ahead, or else if it is greater than or equal to pivot, we need to stop. So once again, I'm repeating: if if uh, if you find that the value of pointer p is less than the pivot, we need to move ahead, or else we need to pause. Then next, uh, move pointer q ahead and until value of q is greater than pivot. So we need to move pointer q ahead until value of q is greater than the pivot. If the value of q is less than the pivot, we need to pause. So once again, and one more thing, important thing is p and q move in opposite direction. So p, since it p moves towards the right side and q moves towards the left side. So after you perform these two steps, the last step is, if you need to check the pointers p and q, you need to check if p and q overlap. If they overlap or cross, we need to swap p and q. Like if they are on the same position, or if the p cross the q position, or if the q cross the p position, we just need to swap p and q. Else we need to swap pivot and q. So basically these are the steps. This might have been a little confusing. We'll just go with an example to make it more clear. So the last step is, if p and q pointers, if their values do not overlap, or if they do not cross, we need to swap p and q. If they cross each other or overlap each other, we need to swap pivot value and q value. So this might all look confusing for you. We'll just dive into the example, and it will be clear there. So this is So if you just look at here, this we have taken it as an example, and pivot is 35, as I said before, that we're going to take first element as pivot, and the next element is p, and the last element would be q. The next element would be infinity. The reason why we take infinity here is, when if you face all the elements less than pivot, you just reach the end of the array, so you don't find anything to compare. So what you do is you assign infinity here, so that infinity is always larger. Hence infinity is always larger. We can just stop the p value here. So we'll just go into the procedure now. So since 50 is greater than 35. So since 50 is greater than 35, p is greater than 35, we just need to stop here and point it as p. Then next we'll just go with q. Since if you see here, 45 is greater than 35. No, we can go ahead. 90 is greater than 35. Yeah, we can go ahead. 20 is less than 35. So we don't need to go ahead. We'll mark this as q. We'll mark this as q. I will erase it here. So if you look at this, you observe that p and q do not overlap across each other. So we can swap 20 and 50. Then again the same thing. We just need to follow the same procedure. So start with p. 20 is less than 35. Yeah, move ahead. 15 less than 35. Yeah, move ahead. 25 is less than 35. Yeah, move ahead. 80 is greater than 35. So we need to mark this as p. Erase p. So the next q, since q is 50 is greater than 35, yeah, we need to move ahead. 80 is greater than 35, yeah, we need to move ahead. Since 25 is less than 35, we just need to point q here. Erase it here. So if you observe, we just what you have done is p and q just crossed each other. If they cross or overlap each other, what we need to do is we need to swap the pivot and q. So when you swap the pivot with q, you get 25 here, and next 35 here. So as you can see, we have reached the optimal position. After reaching the optimal position, you observe that 35, the elements to the left of 35 are always less, and elements to the right of 35 are always greater than 35. So since 35 is an optimal position, the subarray is 25, 20, and 15. So we need to follow the same procedure for it. So uh, take this as pivot element, we'll assign it as P, and we'll do it as P, and the next Q. Yeah. So since we'll just try what you have done is you have assigned 25 as pivot and 20 as P and 15 as Q. So always remember that this since this is a subarray, we'll have infinity here. We can mark somewhere here as infinity for our convenience. It's causing some problem. Uh, yeah, we'll mark I here. Let it be. So what we need to do is so if you check 20 is 20, we'll start with the procedure. 20 is less than 25. We need to move ahead. 15 is less than 25. We need to move ahead. Since I, if you look at this, since infinity is greater than 25, we need to stop here. So what it becomes is I becomes P. So I point, so P points to infinity. Yeah. So P points to infinity here. So the next thing is we need to check pointer Q. So Q is less than 10 is less than 25. So we need to stop here. So if you observe, P and Q crossed each other. So P is at infinity position, and so P is at infinity position, and Q is at 15, and they cross each other. We need to swap pivot and Q element. So what is so after swapping, we get 15, 20, 25. So if you observe, these elements are sorted. So even we can also check with by going through each and every element. We will get the same. We can stop it here. These are all sorted. Then next we'll go to the right side array. We'll assign it as pivot. So since we have NP already here, these 35 we need not move. 15, 20, 25, 35. These are all already sorted. We need not move them. So what we'll do is we'll assign it as pivot, the next P, next Q. Since we have infinity already here, so we don't need to keep separate infinity. Yeah. So here it is P. 50. 50 is less than P. We need to move ahead. 90. 90 is less than pivot. So we need to assign P here. 90 is greater than pivot. So we need to assign P here. Then next Q. So the next is since Q is less than the pivot, we just need to Q is less than the pivot. We just need to stop here. So so if you observe P and Q did not overlap each other, so we can directly swap. So let it be P. We must not change the pointers. 90. Yeah. So if you observe 80. So 45 is less than P. We need to move ahead. Uh, the next followed by 90. 90 is greater than pivot. So we need to assign P to this. So after you assign, you need to remove P here. The next Q. So if you see Q is greater than Q is greater than pivot. So we need to move ahead. And then next 45. 45 is less than pivot. So we'll go with the Q since Q also points to 90. 90 is greater than 80. So we need to move ahead. So if you observe, if we move Q to 45, you see that pivot 45 is less than pivot, so we need to stop it here. We need to assign Q here and remove Q here. So if you see, uh, P and Q crosses here. So we are on the rule that we know the rule that if P and Q cross each other, we need to swap. Uh, we need to swap pivot element and the next and Q element. So what you say is sign 45 here, 80 here. So after you do this, you observe that a pivot changes. So you need to stop here. Uh, if you follow the procedure next, you also observe that it's already sorted. So you don't need to follow the procedure. You need to stop it here. So that's it. As you can see, the the array got sorted, and you can stop it here. So the thing is, we did not cover all the subarrays. So even though if we cover all the subarrays, we just observe the same thing that they are already sorted, and they don't need much. They don't need next process. Uh, that's it. In these applications, quicksort is cache-friendly algorithm, so it is widely used, and it is an in-place algorithm, so it does not require much memory. So it is preferred, and in most commercial projects, we use for scientific and even for scientific research, quicksort is used because its time complexity is very less. So this is basically the time complexity chart, which compares time complexity of quicksort with other sorting algorithms. As you can see, quicksort performs better in the best and average cases uh, than other sorts like bubble sort, selection sort, insertion sort. It performs almost equally well as heap sort and merge sort. So that's it for the session, guys. Keep joining the code CS Saturdays and keep learning.